Okay, now we're going to see how to construct a graph of the cosecant function. We already have a constructed graph of the sine function, or let's assume we already have a graph of a constructed sine function, an unlabeled graph, and this would be an unlabeled graph of the cosecant. Now the definition of the cosecant is fairly simple. It's just the reciprocal of the sine function. Cosecant function is the reciprocal of the sine function. So if you have a value of the sine represented by some constructed distance, you can then construct a representation of a reciprocal length. Now that is, as it's going to turn out, up to our choice of what we want to use for a unit. And we haven't specified any units. So we're kind of free at this point to specify any unit for one, and we'll see how that works out. Okay, so given a segment, okay, well first, if we're going to construct a graph that has values that are the reciprocals of values of some other function, then we'd better be able to construct the reciprocal of a given length. Okay, well, let's see how to do that. Okay, so given a segment of length x, I claim that we can construct a segment of length 1 over x. I'm fudging a little bit in that statement, depends on exactly what I mean, because we don't have any sacred length that represents length of 1. So we can really pick any length we want and make that length 1. The length I'm going to choose, I'm just going to write down a segment here, and I'm going to write down a segment somewhat shorter than x and call this 1. Okay, now I'm going to construct. Now I'm actually not going to do detailed construction, but right there is my length x, and I'm going to I think I want to start with my length 1. Okay, I don't want to start with x. Okay, there's a length 1. Now I'm going to start at a point here, and I'm going to construct a vertical line segment whose length matches this length. Then, and I can construct this, using a compass and so forth. I'm going to attempt to just sketch a line perpendicular to this line. And then open the compass to length x, and I'm going to take a line from here to, or construct a segment from here to here. Okay, and I don't have a straight edge handy, but nothing is very precise, including my right angle. But anyhow, right here we have a representation of a triangle that has length x here and length 1 here. And I probably could enhance things a little bit by making that segment purple. Okay? Now I want to get a segment of length 1 over x. Okay, now motivating this, the ratio of this to this is 1 over x. The ratio of this side to this side is 1 over x. And that is a trigonometric ratio of either this angle or this angle, but that's not what we're talking about right now. If you know that, fine, but it's not important just yet. Okay. So what I want to do now is I want to construct a segment here of length 1. Okay, so this is a segment of length 1, and then I can easily enough construct a perpendicular down to here. So now I've got another triangle, and this triangle is similar to the bigger triangle. I never did really complete the lower side of the triangle, okay? So what is this ratio? Well, I'm hoping this ratio is going to be 1 over x. If it is, then I've constructed 1 over x. If it's not, then maybe I'll learn something that allows me to construct that. So what I can say is that if this side is question mark, okay, then I want 1. Well then, by the similarity of these two triangles, 1 divided by x is equal to what? Question mark divided by 1. Well, it's quite easy to see that question mark divided by 1 is question mark, so question mark must be one over x, so that here I've marked a segment of length 1 over x. And I don't have to make that segment vertical. Since this segment is horizontal, I'm going to go ahead and make this one horizontal. So here is 1 over x. Now that, of course, depends on my choice of 1. Okay, if I let 1 be this distance in constructing the graph of the cosecant function, then 1 is always going to have to be that distance. Okay, so the length of 1 can't be changing from one moment to the next. Once I start constructing reciprocals, I'm going to have to always use the same unit for 1. Okay, well, I'm going to proceed then to construct the cosecant graph, but I'll do that in a separate video.